So a question like this may seem a little bit more difficult because we're given things that we need to find, like amplitude and frequency. However, I guess the only sort of hard part would be finding the frequency, but amplitude should be a walk in the park for most of you guys. So amplitude, something to remember about amplitude is that the amplitude is actually equal to our delta x. And so why is that? Let's say you have a graph over here. Looks a little something like this. It's a wave. The amplitude is this distance right here. So that might seem very familiar actually. It might seem very familiar, just like it is a spring attached like this. And so this distance right here would be our delta x. So that's why amplitude and delta x in this case would actually be the same. So if you wanted to solve this question, all we need to do is we can use our potential elastic energy equation. Instead of writing delta x, I'm actually going to write capital A squared. So we're going to plug in everything we know, 0.5 into my k, which is 240, into my a squared. So 240 times 0.5 gives me 120 a squared, 7.5. 0.0625 a squared, and then if we root both sides, you will get an amplitude of 0.25 meters. So that's amplitude. When it comes to finding frequency, remembering the frequency equation could be a little bit difficult, but if you are given a formula sheet, it should be on there. 1 over 2 pi multiplied by the root of k divided by m. So this is the equation. And so we can simply just plug in everything we know. So 1 divided by 2 pi, which is 6.28, is 0.159. Root my k value, which is 240, and my mass, which is 0.20. So if you solve all of this by plugging that into your calculator, make sure you divide first, and then you can use this big root over here. You should get 0.159 into 34.64. Multiply this, and you get a frequency of 5.5. Remember, the units of frequency is hertz.